Hi, this is Dr. M. Prasad, Assistant Professor, Department of Chemistry, Institute of Aeronautical Engineering. Today, we are going to discussing about chemical corrosion or dry corrosion and their mechanism, effects, and their prevention methods. So, as we discussed about theories of corrosion in previous class, we will discuss about dry corrosion. What is dry corrosion and what is the mechanism which is involved in process of dry corrosion. So as we know, corrosion is the nothing but decay of material by the attack of foreign substances. Foreign substances in the sense whatever different types of chemicals present in the environment due to the attack of these chemicals on the surface of the metal will be degraded. So let us see the dry corrosion. So how we can define dry corrosion? Dry corrosion is also known as chemical corrosion. Why? Because in this type of corrosion process, metal will be degraded by attack of different types of chemicals which is present in the environment. So dry corrosion, it is a nothing but oxidation process. So we know that any corrosion process is the oxidation process. So oxygen in the air react with metal without presence of liquid. That means destruction of material takes place in absence of moisture. That means dry conditions. So dry corrosion is the most visible of our corrosion process. Example, rusty bridges, flagpoles, buildings, and outdoor monuments. So in dry corrosion process, the oxygen has to be able to make contact with the metal surface. Initially, oxygen has to be able to make contact with the metal surface. Initially, this is not a problem, but as soon as corrosion starts to occur, the oxide layer that forms on the metal surface. So here you can see here. So initially, this is the surface of the metal. So oxygen present in the environment attack on the surface of the metal. So initially there is no problem, but as soon as some metal oxide layer is formed due to the attack of oxygen on the surface of the metal. So metal react with oxygen present in the environment, forms metal oxide layer. So you can see here, this is a metal oxide layer. So gradually, the volume of metal oxide layer on the surface of the metal due to the attack of oxygen increases. So the metal gradually degraded by the attack of oxygen. So uniform corrosion, it is a characterized by the corrosive attack proceeding over the entire surface of area. So the large fraction of the total area, general thinning takes place unit failure. So let us see the mechanism. So which type of mechanism, how dry corrosion process takes place? So let us see that. So initially oxidation occurs first on the surface of the metal. So metal is reacting with oxygen which is present in the environment, forms oxide layer. So in the first step, the formation of metal ion which occurs at the metal oxide interface. So due to the attack of oxygen on the surface of the metal, metal undergoes oxidation. So as we know what is oxidation? Addition of oxygen. So amount of oxygen which is present in the environment, it is added or attacked to the surface of the metal. Then what will happen? Metal convert into metal ion by the liberation of electrons. So metal convert into metal ion. So that is the first step in the process of dry corrosion or chemical corrosion. Next step, oxygen changes to ionic form due to the transfer of electron from metal which occurs at the oxide's film. So in the second step, oxygen which is present in the gaseous state, that is converted into oxide ion. How it will convert into oxide ion? By the transfer of electron from metal to oxide, oxygen. Oxide ion react with the metal ion to form metal oxide film. So metal ion is formed in the first step due to the addition of oxygen to the metal ion. Addition of oxygen to the metal ion has been formed. And next, oxygen is converted into oxide ion by the transfer of electron from metal to oxygen. In next step, metal ion plus oxide ion combine to each other, form metal oxide film. Once metal oxide film is formed on the surface of the metal, the process of corrosion will be initiated. That means gradually metal will undergo degradation. Once metal oxide layer is formed on the surface of the metal, metal gradually undergoes degradation. So look at here. Suppose if you take some metal, this is a metal and this one is the surface of the metal. That means top position of the metal. So here oxide is attack on the surface of the metal. So metal convert into metal ions. Then in the second step, oxygen is converted into oxide ion. Oxygen which is present in the environment by taking electrons due to the conversion of metal to metal ions. These two electrons are gained by oxygen converted into oxide ion. So these oxide ion and metal ion join together form metal oxide layer. So the metal oxide layer will be growth which is perpendicular to the metal surface. So this is a metal oxide film. This is a metal. So that is the mechanism of dry corrosion. So initially metal react with oxygen present in the environment. Metal convert into metal ion, and in the second step oxygen present in the environment convert into oxide ion by taking electrons from conversion of metal to metal ion forms oxide ion. These metal ion and oxide ion diffuse towards each other forms metal oxide film. Once metal oxide film is formed on the surface of the metal, it will grow perpendicular to the metal surface. So gradually metal will undergo degradation. So depends on nature of this metal oxide layer. Metal oxide film formed on the surface of the metal plays an important role in oxidation corrosion. So there are four types of metal oxide films are formed on the surface of the metal. Depends on types of chemicals present in the environment. Types of chemicals reacting on the surface of the metal. We can classify these metal oxide film in following ways. That is stable oxide layer, unstable oxide layer, porous oxide layer, and volatile oxide layer. So these four types of metal oxide layers are formed on the surface of the metal. Depends on type of metals, type of chemicals present in the environment. So let us see one by one. So what is metal oxide layer and which type of chemicals reacting with metal stable oxide layer will be formed. Let us one by one. Let us see one by one. First one, stable metal oxide layers and unstable metal oxide layers. So let us see the stable metal oxide layer. That is, first metal react with oxygen forms metal oxide layer on the surface of the metal. So this metal oxide layer is stable. So it does not undergo corrosion and further. So for example, aluminium, tin, lead, copper, etc. forms stable metal oxide layers. Next, unstable metal oxide layers. Here, when metal react with oxygen which is present in the environment, forms metal oxide layer on the surface of the metal that should be very unstable. So immediately decompose into metal and oxygen. So the rate of extent of corrosion is in this case very less when comparing stable metal oxide layer. Why? Because whatever metal oxide layer is formed on the surface of the metal, that should be very unstable and immediately decomposes into metal and oxygen. So this type of unstable metal oxide layers are formed by the attacking of platinum, silver, and gold surfaces. Next, porous metal oxide layer. So especially sodium, potassium, magnesium, lithium. So this type of metals forms porous metal oxide layers. So this type of metals when react with oxygen present in the environment forms porous metal oxide layers. So porous in the sense metal oxide layer contains some holes. So in this case, metal corroded further as O2 can penetrate through the holes. So the rate of extent of corrosion is very high in this case of porous metal oxide layer. Next one is volatile metal oxide layer. So especially molybdenum. Molybdenum forms this type of metal oxide layer. So volatile layer escapes and fresh metal is ready to get attacked. So in this case also the rate of corrosion is increases gradually. So let us see what is a stable oxide layer. The stable oxide layer is fine grained in structure and gets absorbed on the tightly to the metal surface. So stable oxide layer acts as a impervious in nature and stops further oxygen attack through diffusion. So such a film behaves as protective coating and no further corrosion can develop. So examples for stable oxide is aluminum, tin, lead, copper, etc. So oxides of aluminum, oxide of tin, oxide of lead and copper oxides. So this type of metal oxide films are impervious in nature. So if this type of metal oxide layer is formed on the surface of the metal, so there is no further corrosion process. That means decay of metal will be stopped due to the formation of aluminum, tin, lead and copper metal oxide layer on the surface of the metal. Why? Because this metal oxide layer acts as a impervious in nature. Impervious means tightly absorbed on the surface of the metal. So there is no pores. So and there is no volatile of the metal oxide layer. Then whatever metal oxide layer formed on the surface of the metal, it should be very tightly absorbed on the surface of the metal. Next one is unstable oxide layers. So unstable oxide layer is mainly produced on the surface of the noble metals like platinum, silver, gold forms unstable oxide layers. So this type of metal oxide layer is very unstable and immediately come back into metal and oxide, immediately decompose into metal and oxides. So especially gold, platinum and silver, these are our forms unstable metal oxide layer on the surface of the metal. Next, volatile oxide layer. So the oxide layer volatilizes as soon as it is formed on the surface of the metal. Molybdenum oxide is a volatile in nature. So when molybdenum react with oxygen forms very volatile oxide layer. So as soon as this oxide layer will be escaped, then the surface of the metal will be exposed to the environment and, and attack of oxygen on the surface of the metal is very simple. Then the rate of extent of corrosion is rapidly increases in case of volatile metal oxide layer found on the surface of the metal. On the basis of nature of this metal oxide layer or metal oxide film, filling bedworth proposed are classified metal oxide layer as a protective and non-protective. So let us see what is the protective and non-protective metal oxide film. So according to the filling bedworth rule, if the volume of metal oxide layer formed as on the surface of the metal is less than volume of metal oxide layer is, that is porous non-protective. That means the volume of metal oxide layer, just let us consider this is the metal. The volume of metal oxide layer is formed on the surface of the metal is less than the volume of total metal. to be consumed. Then it is a porous and non-protective. So this is a metal, and it is the metal oxide layer which is formed on the surface of the metal. So the volume of metal oxide layer is less than volume of metal. So it is the porous and non-protective. Why? Because approximately half part of the matter is exposed to the environment. So there is a chance and it is a chance to the attack of oxygen which is present in the environment on the metal surface. So this type of metal oxide layer is non-protective. So example for non-protective metal oxide layers are oxides of alkali and alkaline earth metals. And case 2, that is if the volume of metal oxide layer which is formed on the surface of the metal is greater than volume of metal to be consumed. In this case, it is a non-porous and protective. Why? Because look at here. If you see the metal oxide layer, it is completely covers on the surface of the metal surface. So there is no chance of further attack of oxygen on the surface of the metal. Why? Because it is a non-porous. Metal oxide layer is non-porous. So this type of metal oxide layer is known as protective. So example for protective metal oxide layer is oxides of tin and lead. So that is the Pilling Bedworth ratio. So on the basis of metal oxide layer, Pilling Bedworth explain the protective and non-protective nature of the metal oxide layer. So if the volume of metal oxide layer is greater than volume of metal, that is non-porous and protective. So example is lead oxide and tin oxide. Whereas the volume of metal oxide layer is less than volume of metal to be consumed. So in this case, metal oxide layer is porous and non-protective. So example for non-protective metal oxide layers, oxides of alkali and alkaline earth metals. So that is the Pilling Bedworth law or ratio. So the ratio of volume of oxide formed to the volume of metal consumed is called PV ratio, Pilling Bedworth ratio. The ratio between the volume of oxide formed to the volume of metal consumed, that is known as PV ratio. Next, corrosion by hydrogen. So until we have discussed chemical corrosion by the attack of oxygen, and one more type of chemical corrosion, that is corrosion by hydrogen. That means destruction or decay of metal by the attack of hydrogen present in the environment. So let us see how metal will be degraded by the attack of hydrogen which is present in the environment. So here two types of attack of hydrogen on the surface of the metal takes place, that is at ordinary temperature and at high temperature. So let us see, at ordinary temperature hydrogen embrittlement takes place. So here embrittlement is nothing but breakage. So when metal contact to hydrogen sulfide at ordinary temperature causes evolution of atomic hydrogen. So when metal react with hydrogen sulfide at ordinary temperature causes evolution of atomic hydrogen. This atomic hydrogen is diffuses readily into the metal and collects voids where it recombines to form molecular hydrogen. So if the volume of molecular hydrogen is gradually increases, yet voids of the metal. So gradually volume of molecular hydrogen is increases. So it will embrittlement occurs. So that is a hydrogen embrittlement. So this type of destruction process takes place at ordinary temperature. So correction of these hydrogen gases in the voids develop very high pressure which causes cracks and blisters on metal. So this process is called hydrogen embrittlement. Next one is decarbonization. So it takes place at a high temperature. So at high temperature, atomic hydrogen is formed by the thermal decomposition of molecular hydrogen. So when this type of destruction process is possible in case of alloys. So what is a alloys? It is a mixed metals. When steel is exposed to this environment, atomic hydrogen readily combines with carbon of the steel and produces methane gas. So if the volume of methane gas increases gradually, so decarbonization process takes place. So we know that here steel is nothing but Li. What is the composition of steel? Carbon plus iron. So here decarbonization process takes place. That means removal of carbon takes place due to the attack of hydrogen at high temperature. So methane gas is formed. So gradually the volume of methane gas is increases. Because of this methane gas, breakage of metal will take place. So this type of decarbonization will take place at high temperature. So correction of methane gas voids develop very high pressure which causes cracking. Thus the process of decrease in carbon content in steel termed as decarbonization of steel. Okay. And the third type of electrochemical corrosion, that is liquid metal corrosion. So we know that what is a liquid metal. So what are the examples for liquid metals? Mercury and sodium. So liquid metal, what is a liquid metal? How we can define? The metal which shows properties of both metal and liquid. These are the liquid metals. So this liquid metal corrosion is due to the chemical action of flowing liquid on the metal surface at high temperature. So the destruction process involves either dissolution of solid metal by a liquid metal or liquid metal may penetrate into the solid metal. So that is the liquid metal corrosion. In this process, either dissolution of solid metal by a liquid metal That means when throwing of liquid metal on the surface of the solid metal itself dissolves, or liquid metal may penetrate into the solid metal. So whatever liquid metal, it will penetrate into the solid metal, and solid metal will undergo degradation. So that is the liquid metal corrosion. So that is the electrochemical corrosion or dry corrosion. So this type of corrosion takes place in absence of moisture. That means it is initiated by reacting of whatever chemicals present in the environment. So it is three types of dry corrosion process takes place. That is oxidation corrosion, corrosion by hydrogen, and liquid metal corrosion. So in oxidation corrosion, the metal will be react with oxygen present in the environment. So due to the attack of oxygen on the surface of the metal oxide film is formed on the surface of the metal. So these metal oxide layers are generally four types: stable metal oxide layer, unstable metal oxide layer, volatile metal oxide layer. So depends on nature of metal oxide layer, building Bedworth explains the protective and non-protective of the nature of the metal oxide layers. So that is known as PV ratio. And next, corrosion by hydrogen, that is hydrogen embrittlement and hydrogen decarbonization. And last one is the liquid metal corrosion. So that is about chemical corrosion. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.